Hi everyone, my name is Ajay Bardaki. This is my lab one, the tape lab for Modern Physics 2. For an introduction, the purpose of this lab is to understand how two pieces of tape are going to move based off their different charges and to identify these charges based off of our experiment. We're going to be covering concepts like Coulomb's law and Newton's second law, and we're using glow script to model our charges, the magnitudes of gravity, and our electric forces. And then the result is that the tapes repulse each other because both had a positive charge, which we will find out later. So the concepts we're using, Coulomb's law, which is to calculate the force between two charged particles, as shown there. And then also Newton's second law. This is also to calculate the gravitational force, which in this situation we do have to factor that in due to the nature of the experiment. So our initial conditions, the system tape B is the one that we were holding up against the other tape. And then the surroundings are tape A, that is like the thing that we're acting on. And then the Earth is also causing a force on the tape B. So tape conditions, we'll have the mass, length, and width calculated based off the given density. And then we're going to assume no other external forces just for simplicity because forces at this size and experiment would be negligible. So one of the things to note is that the distance between the tapes before they start levitating is 0.029 meters. And then here's our little procedure on what we did for actually finding this value. So here's our glow script model. And now I made this so that I can find out what the gravity was on the tape and what the charge was on the tape. So we can use this to calculate that the gravity was 0.0196 newtons in the negative direction, implying that the gravity was acting downwards on it, which makes sense. And then the charge on the tape was 4.2 times 10 to the negative 7 newtons. And this is telling us that the charged particles are interacting with each other and exerting that force. And due to the reciprocal law, we can say that it is the opposite force for the other tape. So here's some assumptions that we made along the way. We're treating both pieces of tape as point charges rather than bodies. This actually makes a huge difference because there's a lot of surface area and like polarization that would go along with treating each piece of tape as a body. So we simplify this down and say it's a point charge of the two closest points to one another, and that way we can kind of use the equations that we need using so far. We also assume that there's only two forces involved, more possibly. In the prompt, it said air resistance, but you can also like heat and friction are always like applicable. But in this case, air resistance would be a force in the opposite direction that would prevent the tape being repelled. So that is something that we do need to note that in our consideration. We treated both tapes as having the same charge. They might vary in charge, but that's something that we'd have to do a more complicated experiment for. And then another possible source of error is setting up the experiment incorrectly, giving the tape wrong charge, or somewhat discharging it. This we'll talk about in the next slide. The what if. What if electrons had a positive charge and the protons had a negative charge? What would change about the observations you made with your tapes and other charged objects? Well, if it was flipped polarity, then we would experience like flipped results. So anything that would repel would be attracted and so forth, just because of the nature of like laws of attraction. And then why is it important to handle the charged tapes as little as possible? And then what happens when it comes in contact with your hands or other objects? When you charge the tapes, they are charged with that many like electrons at that given moment. But when you start interacting it with others, those electrons are going to discharge on other objects or kind of net out to zero, like with your hand per se. So it can cause inconsistent results due to that, and we might not get the same accuracy of results and data from it if we were to properly get the right charge without any discharge or touching it at all. But that is it. Thank you for listening to my presentation.